In this video, we will learn about basic logic gates. In electronics engineering, there are two types of signals: analog signals or time-varying signals, and digital signals with only two levels, either 0 or 1. Logic gates are the basic building blocks of a digital system, which receive digital signals as input and generate output based on some logic between the input digital signals. For each logic gate, there is a logical relation like and, or, not between its inputs and output. A logic gate which follows AND logic is called as an AND gate. For a two-input AND gate with A and B as the inputs and Y as the output, if A and B is equal to 1, then Y is equal to 1, else Y is equal to 0. A logic gate which follows OR logic is called as an OR gate. For a two-input OR gate with A and B as the inputs and Y as the output, if A or B equal to 1, then Y is equal to 1, else Y is equal to 0. A logic gate which follows NOT logic is called as a NOT gate. If A not equal to 1, then Y is equal to 1, else Y is equal to 0. Now let us discuss basic logic gates in electronics. Basic logic gates are AND gate, OR gate, and NOT gate. So these are the symbols of AND, OR, and NOT gates respectively. So here for the AND gate and OR gate, there are n number of inputs and only one output. And for a NOT gate, there is only one input and one output. Now let us discuss a two-input AND gate. The two inputs are A and B, and Z is the output. So the output Z follows the relation Z is equal to A and B. The logic operation of this gate can be summarized as: if A and B is equal to 1, then Z is equal to 1, else Z is equal to 0. That means, if both inputs are existing at logic 1, then output is also at logic 1, else output will be logic 0. And this can be generalized as in the case of an n input AND gate. If all the n inputs are existing at logic 1, then output is equal to 1. Else, if any one of the input is existing at logic 0, then output is equal to logic 0. So this is the truth table of a two-input AND gate. So if both A and B are existing at logic 1, then output is equal to 1. Else output is equal to 0. So in the first three rows, any one of the two inputs is equal to 0. So output is equal to 0. And in the last row, both inputs are existing at logic 1. So output is equal to 1. If A is equal to B is equal to 0, then Z is equal to 0. If A is equal to 0 and B is equal to 1, then Z is equal to 0. If A is equal to 1 and B is equal to 0, then also Z is equal to 0. And if both inputs are existing at logic 1, Z is equal to 1. The truth table of an AND gate can be summarized as, for an AND gate with n inputs, if all the n inputs are at logic 1, then output will be at logic 1, and if any one of the n input is existing at logic 0, then output is also equal to logic 0. Now we will consider a 2-input OR gate. For the 2-input OR gate, A and B are the inputs and Z is the output. So the logic relationship between output and inputs is Z is equal to A or B. The OR operator is represented as a plus symbol. The logic operation of this gate can be summarized as, if A or B is equal to 1, then Z is equal to logic 1. Else, if both inputs of the OR gate are existing at logic 0, in the case of a 2-input OR gate, then output is equal to 0. So this is the truth table of an OR gate. If both inputs are existing at logic 0, then output is equal to 0. If any one of the two inputs is existing at logic 1, then output is equal to 1. If both inputs are 0, output is equal to 0. If any one of the two inputs is equal to 1, then output is equal to 1. So the truth table of an OR gate can be summarized as, for an OR gate, if any one of the n inputs is existing at logic 1, then output is logic 1. Else, output is equal to logic 0. So if none of the n inputs is existing at logic 1, then output is equal to logic 0. Now we will consider a NOT gate. So for the NOT gate, there is only one input and one output. A is the input and Z is the output. So we can relate output and input logically as Z is equal to NOT A. The logic operation of this gate can be summarized as, if A is not equal to 1, then Z is equal to logic 1. Else, Z is equal to logic 0. So this is the truth table of a NOT gate. If A is equal to 0, Z is equal to 1. If A is equal to 1, then Z is equal to 0. So the truth table of a NOT gate can be summarized as, if the input is not logic 1, then output is logic 1. Else, output is at logic 0. Thanks for watching Circuits Analytica. Enjoy learning. Please comment, share and subscribe our channel.